This is practice A for section 10.3. We're going to find the chord length. In number 1, they want you to find the length of chord AB. So this chord would just be that segment AB. How long is that segment? Well, we have arc AB that has a measure of 155, and we have arc DC that has a measure of 155. When you have two arcs that are the same measure from the same circle or congruent circles, then the chords that correspond to them, they're going to be congruent. So notice how chord segment CD has a length of 9. So does segment AB. It would have a length of 9 as well. That's how theorem 10.3 works. Now, there's a converse to that as well. So let's say you have two chords that are congruent in a circle or in congruent circles. What do you know about the arcs that correspond to them? They're going to be congruent too. So notice how arc WZ has a measure of 105. Arc XY is also going to have a measure of 105. That's also theorem 10.3. That's the converse of it. Next section down. Tell whether segment QS is a diameter of the circle. And this would be circle C. So point C is the center. If not, explain why. It doesn't really look like point C appears on any of these. That's weird. All right, so theorem 10.4 says that a chord is a diameter if it's a perpendicular bisector of another chord. So notice how we have a chord right here. And here's two important things that happen. One thing is it bisects that chord at a right angle. When both of those things happen, then that is a diameter. So you would say yes to this one. Segment QS is a diameter by theorem 10.4. Now, if you're missing one or both things, then it's not a diameter. Notice how this segment has a length of 20 and this one has a length of 19. It has to be bisected at a right angle. You got the right angle, but not bisected. Okay, notice how we are bisected here, but there's no right angle until you realize these two angles are congruent. They have to be 90 each because it makes a line. Number 10, segment LK and segment KN, are those two measures the same? You can't tell. Now, if that was a diameter, things would be different, but it's not a diameter necessarily. Like for example, I could draw you this circle. I could put a chord here, and I could put a chord here, and we could have that right angle right there. Does that mean that this segment and this segment are congruent? It doesn't. Okay, now if this segment was a diameter, then that would change things, but it's not. Okay, so here we do have a diameter. Does it cross that chord at a right angle? So let me show you what this could look like. What if it looked like that? Would you say that this was the same as this? Probably not. You need the right angle. It sure looks like it's a right angle here, but it's not marked, so you can't really say for certain. Okay, now number 12 has both things that you want. You have a diameter that's crossing a chord at a right angle. So it is going to bisect the chord, and it's also going to bisect the arcs. And that's theorem 10.5. I didn't have that written there. It's the converse of theorem 10.4. Okay, so we're doing the same thing in that section there. So here's an example right here. You have a diameter. It's meeting a chord at a right angle. When that happens, the chord gets bisected and so does the arc. So measure of arc JK is 55.